Perspective Class 2 Video 2. In this video we're going to talk about the slope-intercept form of a linear equation. Recall that a linear equation is any equation in terms of x and y and constants that does not involve higher powers of x and y, and it does not involve products of x and y either. So what's the slope-intercept form? Well, the slope-intercept form is just a linear equation that looks like this. That looks like y equals mx plus b. This is the slope-intercept form of a linear equation. And the m and the b have special names. M is called the slope, and what it means is the change in y per change in x. Okay, we'll talk more about slope later on, but this is what the slope of the line means. It means how much does the y value change every time you change the x value by 1 unit. Right? So if you move 1 unit to the right, how much does the vertical change? And b is called the y-intercept, or just the intercept, and it's the value at which the line intercepts the y-axis. So if I just do a very quick example, I will draw the coordinate axis and I'll draw some sort of line like this. Okay, then what do we have? Well, this point here is the point B, whatever value that is. And how do I find out what the slope is? Well, you look at this here, which is like 1 unit in the x direction, and you sort of consider how much does the y direction change. Okay. Or another way of thinking about this is I could draw a bigger triangle like this, and I could say like this is the change in x, this is the change in y, and m is the change in y divided by the change in x. Okay, we'll talk more about slope in detail later on. One thing I want to mention is most equations can be written in slope-intercept form. So most linear equations can be written in slope-intercept form. But I wouldn't say most unless there were some which can't. And there are some linear equations that just, it's impossible to write them in slope-intercept form. But most of them can be written in slope-intercept form. Okay? In fact, the only equations that cannot be written in slope-intercept form, the only linear equations that cannot be written in slope-intercept form are equations of the form x equals a for some constant a. But we'll do more details on this later. For now, let's do some examples of writing an equation in slope-intercept form. So on the left I have linear equations, and on the right I want to write the same equation in slope-intercept form. Well, the first one is very easy because it's already done. It's already in slope-intercept form, so there's absolutely nothing I need to change. 2 is the m and 1 is the b. It's already in slope-intercept form. The next one isn't in slope-intercept form, but it's easy to get into slope-intercept form. The trouble is there's a 4 on the left, and I want only y on the left, so I just move the 4 to the right. Okay, so I end up with y equals 3x minus 2 minus 4, which I can simplify to just minus 6. Okay, it's the exact same equation. I've just written it in a different form. The next one, this one here, it's not in slope-intercept form at the moment, so what do I need to do? Well, I need to do two things. I need to move the x's to the right, okay, and maybe I'll do it here so that I can have some intermediate steps. So I have 3y equals 2x plus 5, and now I need to divide both sides by 3. So I have y equals 2 over 3x plus 5 over 3. And that's the answer. So I'll write that in here. And then I'll erase this work here. Okay. The next one, y equals 4. This one's sort of like a trick question almost, because it is actually already in slope-intercept form. I have y equals 4. Or if you want, you could write this as y equals 0x plus 4. Or just y equals 4. They're both perfectly correct. Okay. 0 is m, and 4 is the y-intercept. Okay, so I would probably just write it like this to save myself some time and writing, but if you wanted, it's also perfectly correct to write it like y equals 0x plus 4. Finally, this last one definitely is a trick question, because it's not possible to write x equals 7 in slope-intercept form. There's just no way of doing it, because x equals 7 is in the one format which is impossible to write in slope-intercept form. Okay? So why do people care about slope-intercept form? Well, if an equation's in slope-intercept form, it's quite easy to plot. It's quite easy to sketch that equation. Let's look at this example here. So this question says, plot this line right here. 3y plus 2x minus 1 equals 6x minus y plus 7. So this is a very confusing looking equation, linear equation. The first thing I'm going to do is put it into slope-intercept form. So I'm going to put all the y's on the left. So that's 4y. I moved this to the left. And now I'm going to move this 2x to the right. And I'll move the minus 1 to the right. So I have 4y equals 6x plus 2x plus 7 plus 1. I'm sorry, I'm bad at equations. When I move this to the right, it should become a minus. So 6x minus 2x plus 7 plus 1. So that's 4y equals 4x plus 8, and now I divide everything by 4 just to get y equals x plus 2. Okay, and now when it comes to plotting this, it's a lot easier of a task. It's the same line, it's just in the nicer form, because all I need to do, if you recall, to plot a line is find 2 points which lie on the line. Well, it's easy to find 2 points which satisfy this equation. I mean, I could plug in x equals 0, and then that gives me y equals 0 plus 2, which is 2. I could plug in x equals 1, that gives me y equals 1 plus 2, which is 3. So my 2 points are 0 and 2, and 1 and 3. So if I draw a coordinate axis like this, 1, 2, 3, 1, 2, 3. My 2 points I z are 0, 2, and 1, 3. So the line is the line that goes through these 2 points. Like that. So this pink line right here is this line right here. Okay? So this is one use of the slope-intercept form. It makes it easier to plot linear equations. Next, I want to talk about this very important theorem. This theorem tells you how to interpret the slope. Okay? So first of all, it says if you have any 2 points, and I'm writing my points like this, x1, y1, x2, y2, on a line, then the slope of the line is given by this formula. Okay? And the way you think about this is it's the change in the y divided by the change in the x. You know, it's the difference between the 2 y coordinates divided by the difference between the 2 x coordinates. So geometrically, what this is looks like is as follows. If you have your line, geometrically, you're choosing 2 points, x1, y1, x2, y2, and then this distance here is y2 minus y1, and this distance here is x2 minus x1. So you're doing this divided by this. That's the slope of the line. Okay? So that's how you find the slope of a line if you have the line already drawn. And how do you interpret the slope? Well, if the slope is positive, if it's a positive number, then the line is going uphill. So the line looks like that. If the slope is 0, then the line is horizontal. If the line is negative, then the line is going downhill. So it looks like that. And finally, if the line equals plus or minus infinity, and I should probably put this in quotation marks because, you know, this nothing actually equals infinity, because infinity is not a real number. But it's an abuse of notation, right? And you can't stop me from doing it, so I'm going to do it. So if m equals plus or minus infinity, it's vertical. And what I mean by plus or minus infinity is technically like the bottom disappears. So like x2 minus x1 equals 0, but y2 minus y1 does not equal 0. That's what I mean by m equals plus or minus infinity. Okay, so let me write that quickly. This here, what I mean is x2 minus x1 equals 0, and y2 minus y1 is not equal to 0. But it's a lot more easy and convenient just to write plus or minus infinity. Okay, so this is how you interpret the slope of a line. And the final remark I want to make is that the only lines that can't be written in slope-intercept form are vertical lines. Because vertical lines have like infinite slope, and it's not okay to say something like this. This is just, it's not okay to write something like this, because you can't use this infinite sign like you would a number. So the only lines that can't be written in slope-intercept form are vertical lines, because if you could write them in slope-intercept form, you'd have to use infinity, but you're not allowed to do that. So vertical lines you write simply as like x equals a. Okay, and the way you would plot this is, if this is a, then this line right here is x equals a. Okay, it's all the points where the x coordinate is equal to a. That's the end of this example, and that's the end of this video.